And let's see this is correct. And the way we can see this is correct is if you go on Wolfram Alpha, but before you do that, make sure you like, comment, subscribe, and fucking leave a hate comment, because any comment fucking helps, okay? Okay, we got a differential equation. We could try to fuck ourselves and go Laplace method, but why don't we just use method of undetermined coefficients? Start by representing this as a polynomial, so m squared plus m plus 1, setting it equal to 0. Don't worry about the right-hand side for now. Let's just worry about this. Okay, so is there anything that makes this look nice? Not really. We kind of have to just jump to the quadratic formula. So I'll write it out. It's always good to write it out just for your own memory. It helps you remember it. And I encourage remembering this. Okay, negative b. What is b? b is 1. It's negative 1 plus minus 1. 1 minus, okay, 4 ac. A and c are both 1, so just minus 4. A is 1, 2. So we have negative 1/2 plus or minus, and this will be negative 3. So notice that we have a negative 3. This is the same thing as I, imaginary 3. Okay, so we can write it like that. There we go. Okay. So that's our roots to this polynomial. Okay. Now, since we know that, we can represent this using our general form. C1. Second. E to the what? E to the alpha x. And maybe I should let you guys see that this is alpha plus or minus I beta. So we got e to the alpha x, C1 cosine beta x plus C2 sine beta x. And what does this equal? Well, for us, it's going to be e to the negative 1/2 x. C1, we don't know C1, so we'll call it C1. Cosine, what is beta? Beta is square root over 3. So cosine 3 over 2x. Similarly, C2 sine square root 3 over 2x. And I'm going to erase that now so it doesn't look like it's equal. Okay. That's our complementary solution. You need a particular solution with this. So, what can you do? Well, for your particular solution, you have a right-hand side which is a polynomial, right? It's x squared. You could represent a polynomial in its most general form as ax squared plus bx plus c. And then now you can use this and recreate this differential equation with just this. So you'd see y prime of p is 2ax plus b. Y double prime of p is 2a. And then now when you're recreating your differential equation, we're going to do it right here. It's going to be 2a plus that 2a x plus b plus that over there, which is ax squared plus bx plus c. And it's equal to x squared. Okay. So now we can try to identify what a, b, and c are. So if we're just worried about x squared, using the concept of linear independence, we can do this. We can just drop it down. Do we have anything x squared here? We have an a here, and on the other side we have a 1. Well, a is equal to 1. Nice to know. Okay. What else? We have a 2a. Let's worry about x's here. So we have x. There's a 2a next to it, and then there's a plus b here next to it, and there's no x on this side, so go to 0. Okay. And let me write it, write it like this, okay. So 2a plus b is equal to 0. So you can see that b is equal to negative 2a, which is equal to negative 2 because a is equal to 1. Okay. Same idea, let's go one step farther. So we have 2a plus b plus c equal to 0. What does this mean? Okay, negative a is 1, so we go 2 minus 2 plus c. Oh my god, c is equal to 0. Alright, so we can rewrite yp specifically as what? We can write it as yp is equal to x squared minus 2x. This is yp. This is kind of important. Yc is also important. So we know that our actual solution is yc plus yp. So we're going to do that. Okay. So yc, what is yc? Okay, we have it here. So what does y mean? E to the negative, I'll write this as x over 2. c1 cosine square root 3 over 2x plus c2 sine square root 3 over 2x plus x squared minus 2x. And we're going to plug in our initial conditions now. So if this is y of x and y of x is 0, I mean y of x is negative 1 for all x's is 0. So we can write this as y of 0 equal to negative 1 is equal to this. This will be 1. Cosine of 0 is what? It's just 1, so c1. And that, everything else is just there. So c1 is negative 1. Okay, what about c2? Okay, so we can do the same thing. Just we need to take a derivative here. Okay, so we had 2 unknowns. We need 2 equations to solve 2 unknowns. So that's why you got to take the derivative. So y prime, taking the derivative of everything over here with respect to x, what do you get? You get negative 1/2 e to the negative x squared. And this inside stays the same. c1 cosine square root 3 over 2x plus c2 sine square root 3 over 2x. And then now you're going to take this derivative and keep that exponential the same. So it would be e to the negative x over 2. And then it would be negative square root 3 over 2 c1 sine square root 3 over 2x plus square root 3 over 2 c2 cosine square root 3 over 2x. And then plus 2x minus 2. So a lot of work for one derivative. I know, it's terrible. Okay. Y prime of 0, that was our initial condition, is equal to 1. So everything that's x will turn into 0. This will just be negative 1/2. c1 will stay. This will be 1. This will be 0 because the sine, the cosine will stay. So it's going to be square root 3 over 2 c2, and then plus, oh, this is a 0. This will become a 0. That will be stated minus 2. Okay, so now we can use and solve for c2. Okay, so 1 is equal to, okay, c1, why don't we plug in c1? So negative 1 goes here. This will become positive 1/2 plus square root 3 over 2, c2 minus 2. Solving for c2, add the 2 on the other side, turns into 3. Multiply everything by 2, this 3 turns into a 6. Okay, now we have 1 plus square root 3 c2. We can see that c2 is equal to 6 minus 1 is 5. 5 over square root 3. Okay, so a lot of work. And we've now just found what c1 and c2 is. Okay, so I'm going to erase up here because I need to write my answer somewhere. Okay, so y, this is the answer, right? We had a lot of little mini answers, but this is the final answer. It's e to the negative x over 2. c1 was negative 1. Negative 1 cosine square root 3 over 2x plus what? Plus c2 is 5 over square root 3 sine square root 3 over 2x. And then what's the next stuff? Plus x squared minus 2x. Done.